18. Today we are going to talk about graphing cosecant and secant as well as tangent and cotangent. So if we look at the parent functions of our secant graph, note that wherever we see a max or a min of our cosine graph, we will see a parabola looking shape for the secant, and anywhere that our cosine graph touches the midline, we see a vertical asymptote. So this is the true graph we see of it. However, this is the connection then we see with that cosine graph inside there. Same kind of idea with this, the cosecant graph. We look at the sine graph, and anywhere again with our sine graph that we have a max or a min, we see a parabola. Anywhere we are touching the midline, we have a vertical asymptote. So what we notice is as we graph these two reciprocal functions, we're really focusing on graphing our two parent functions here of cosine if we are graphing a secant graph, or the sine graph if we are graphing cosecant. So essentially that's what we want to do each time, is sketch in lightly those original graphs. And then again, depending on which one you're doing, anywhere you touch your midline, you will draw in vertical asymptotes. So again, where it touches the dashed line, dash horizontal line. And then for part 3, we will draw in, again, the U-shapes away from the center of the graph, anywhere we see the peaks and valleys, the maxes and the mins. Make sure you always erase the original cosine and sine graphs if you drew them in, because they are not officially a part of your answer, only a tool to help us with the secant and the cosecant. So for our parent function of secant, again, we want to really actually start with the graph of cosine of x, since that's its reciprocal function. So our normal graph of cosine, we repeat by the time we get to 2 pi. Our graph goes up by pi over 2 each time. We start at our max, and we touch the midline, go down to the min, back to the midline, back to our max. So anywhere we are touching that midline, we want a vertical asymptote. Anywhere we see a min or a max, we are going to put a parabola shape, a U, away from the center, so go in that opposite direction. So we see here this sketch of our secant graph. Note that the vertical asymptotes each time are going through pi over 2, 3 pi over 2, it ended up going through 5 pi over 2, aka pi over 2 where it is odd, so 2n plus 1. For our parent function then of cosecant, that is going to be 1 over our sine of x. So again, we have our parent function of sine that repeats by 2 pi, and each time we are going up by pi over 2. Sine starts on our midline, goes up to the max, back to the midline, down to the min, back to the midline. And again, anywhere we touch the midline, so at 0, pi, 2 pi, we see vertical asymptotes. And then at that max and that min, we see our U-shape parabolas going away. So this time for our vertical asymptotes, again, they're going through 0, pi, 2 pi, aka x equals pi times n would be the location of those vertical asymptotes. Now our graphs of tangent and cotangent are again kind of based off of, if we think about our unit circle, what is happening each time. So if we start at 0, we would be doing 0 divided by 1. So at 0 degrees or 0 radians, we are at 0. Up at pi over 2, however, we would have 1 divided by 0, so that's undefined. So that's why we see for tangent why we have this vertical asymptote through pi over 2. Then we get to pi, where we would take 0 divided by -1, so that would just be 0. And then down here we have 0, -1, so again, -1 divided by 0, we see that vertical asymptote because that's undefined, back to 0. So we see this shape of our tangent graph kind of taking shape here. And then our cotangent graph, on the other hand, if you think about, since tangent is y over x, cotangent is x over y. So it almost flip-flops, right? We are undefined because we're taking 1 divided by 0 at 0. Then we are at 0, undefined, 0, back to 0. So with these graphs of tangent and cotangent, okay, another thing to note, they're repeating more often. Their period, something important to note here, is only going to be pi, not 2 pi. So that's something very important to note for these two graphs. So by the time we make it to pi, our graph is actually going to repeat itself for cotangent. It has a vertical asymptote through 0 and also through pi. And our graph with the cotangent, think about pi over 4, we'd have a cotangent value of 1, 0, -1, and then we have that vertical asymptote. So again, these cotangent graphs, if we sketch a couple of these in, every pi they're repeating, and again, we have this kind of decreasing always nature with them throughout. The vertical asymptotes, similar to our cosecant graph, occur at pi n each time. Now, our graphs of tangent, on the other hand, again, start at 0, and then at pi over 4, we're at 1, and then we have that vertical asymptote when we get to pi over 2. And then if we went to negative pi over 2, we would have this vertical asymptote here, and through here we see that always increasing nature with tangent. And again, its period is only pi, and we repeat, again, every pi, we see another one coming in. So we see this time that our asymptotes are happening similar to secants at pi over 2, 2n plus 1 each time. All right, we will definitely be working more with these parent functions in class. Thanks everyone for watching.